Right, so let's focus on the part D again. Now, once you have an inductor in an AC circuit, we know inductor's reactance is given by omega L. So there are two situations. The inductor can be having air as the core, which has permeability of 1, or the inductor can have the soft iron core and the permeability. If you see the formula of inductance, that means inductance is directly proportional to permeability of the core. So if L goes up because you introduced a higher permeability such as iron, the overall reactance of the inductance will go up because it is given by omega into L. So you see I've calculated XL, which is inductive reactance in air, and then I've calculated inductive reactance in iron and used omega L mu. If you divide the two, you will get that the inductive reactance with iron, which is XL dash, is much more greater than inductive reactance in air. Now the overall impedance of the circuit is given by XL square plus R square. XL has increased, so overall impedance of the circuit will increase, and therefore the overall current in the circuit will decrease, and that is why the reduced current will appear like that. The lamp is now much more dimmer, and the brightness goes down. Thank you.